Hello guys, welcome to the mathematics lesson. In today's mathematics lesson, we'll be looking at a lesson in matrices or a mathematics lesson called matrices. So that's what we'll be looking at, matrices. So guys, it's very important you understand what a matrix is, because the word matrices, it just means plural. Like you have many matrices, but if you have one matrix, you call it a matrix. So what is a matrix? So we are going to say a matrix is, okay, sorry, a matrix is an array of numbers. A matrix is an array of numbers, okay? So now, numbers in a matrix are called elements. So numbers in a matrix are called elements. So I'll give you an example. Examples of matrices. So if I come up with an array of numbers or an order of numbers or an arrangement of numbers like this, A, we say I have 4, 2, 6, then 3, 1, 0, like this. Then I have B, I have maybe 0, 1, 6, 4, then maybe I have 3, 7, then 0, 1, then maybe 5, then 4, 8, 9, like this. This one also is a matrix. So these two are examples of matrices because they are an array of numbers or an arrangement of numbers. So this one is a matrix and this one is a matrix. Now, numbers in a matrix are called elements. So these numbers in this matrix are called elements. Like this matrix A here has got how many elements? 1, 2, 3, 4, 5, 6. This one has got how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So these are examples of matrices. So it's very important that you understand these things, guys. Okay. So each number here is called an element. So another important concept that you need to understand about matrices is what we call order of matrices. It's very, very important that you understand this concept. What do we mean when we say order by matrices? So order of a matrix is given by multiplying the number of rows with the number of columns. So we're saying order of a matrix is given by multiplying number of rows of a matrix with number of columns. So that's what we find, what we call, when you hear order of matrix, it means you are trying to give the number of rows in a matrix, then multiplied by a number of columns. Okay. So what are columns? Columns are actually vertical lines in a matrix. Like this one, these are columns. And then rows are horizontal lines in a matrix like these ones here. Okay? So very important you understand that. So let me give you an example. So example here. Okay. So example here says find or determine, let me just say determine the order of the following matrices. Determine the order of the following matrices. So I have like A, I have this matrix which says 1, 4, 6, 2, 3, 0. Then B, I have like 2, 6, 1, then maybe 7, 5, 3, then 6, 1, 4. Okay. Then I have another one like C. Then I have another one which is like 3, 4. Then the last one I have like a D. I have 1, 3, 6, like this. So, okay, so I have these matrices here. So we need now to determine the order. So let's use this other part here. So me, when I'm teaching, I always give definition for the reason so that because definition like these concepts are what someone needs to know in order to answer a question or know a topic. So when we say determine the order of the following matrices, like A, we have this one here, which is 1, 4, then 6, then we have 2, 3, 0. So we need to determine the order. We said the order is given by multiplying number of rows of a matrix with the number of columns. So we need to know the rows here. Rows, I said these are horizontal straight line. So here we have 1 and 2. So we have 2 rows. Then the columns, I said these are vertical straight lines. So we have 1, 2, 3. The line that can pass through these numbers are 3. So you can say we have 3 columns. So in this case, to give now the order of this matrix, you multiply rows by columns. So you say 2 by then 3 matrix. So this is the order of this matrix. It is a 2 by 3. So sorry, here there is a 3 because of the reflection of light. So I can say we have 2 rows here, and then we have 3 columns. 1, 2, 3. 3 columns. So it is a 2 by 3 column. Then let's answer B. B we have 2, 6, 1. Then we have 7, 5, 3. Then we have this is 0, 1, 4. 0, 1, 4. So we need also to determine the number of rows and columns. So rows are these vertical lines that pass through these numbers. I mean horizontal lines, 1, 2, 3. So we have 3 rows. Columns are these lines that pass through these numbers. The vertical one, 1, 2, 3. So we have also 3 columns. So now this one can be reported as a 3 by 3 matrix. And because the number of rows is equal to the number of columns. This one is called a square matrix. Why? Because the number of rows is equal to the number of columns. So very important to understand that. So let's look at this C. C we have 3 and then 4 like that. So what is the order of this matrix? So the vertical, the horizontal lines that can go through this number 1, 2, there 2. So meaning we have 2 rows. Then the vertical ones that can go through this number, this is just one line. So we have 1 column. So this one can be reported as a 2 by 1 matrix. Then we can come to this one D here. D we have a 1, 3, and 6 like that. So we have only one line that can go through these numbers, and you know a horizontal line that goes through the numbers stands for rows. So meaning we have one row, and we have how many columns? The number which can go into these 1, 2, 3, the lines. So we have 3 columns. So meaning this one can be given as a 1 by 3 matrix. So it's very important you understand these concepts. Very important. Now, the next concept that we are going to look at is actually, I will look at the transpose of a matrix. So we need to look at this concept, which is transpose of a matrix, which is represented by letter T like that. So we have to understand what is actually a transpose of a matrix. So this is just a change of a matrix or a change of the order of a matrix. So transpose is just a change of the order of a matrix. So here the rows becomes columns and then the columns becomes rows. So we're saying rows become columns, and then columns becomes rows. That's what it is. So a transpose of a matrix, you're saying it is just a change of the order of a matrix. Rows become columns and columns become rows. So this is how we do it. So example, this is example. So if we have, so we're saying if matrix M is equal to, we have it as 1, 2, then we have 3, then 7, then we have 8, then 9. Okay. Then if we say A T, it means the transpose of this matrix where we need to change the rows, they become the columns, and then the columns become the rows. So here we have these are the columns, so they should become the rows. Like this column, this one should become the row. So it will be 1, then you say 3, then you say 8, then you come 2, then you say 7, then you say 9, like that. So this is a transpose. We have changed it. The columns have become the rows, and then the rows here, they have become the column. Okay? So that is it, how it is. So here, this one has become the row, like 1, 3, 8, 1, 3, 8, and this one 2, 7, that. So we have this one has become actually the row here, and this one 3, 7, 18, 9, like that. Okay? So it is very, very important to understand that. Okay? Then we can also say if we have matrix B is equal to, where we have 4, 2, then we have 1, 3. And we're saying then if we have B transpose, it means we change. So these are columns, they become rows. So you have a 4, 1, so 4, 1, then 2, 3, you say 2, 3, like that. So I hope you understand these concepts. Now we have to go to addition and subtraction of matrices. So we are looking at addition and subtraction of matrices. So sorry for the reflection which is here. I hope you will be able to answer, to see. So we are saying matrices of the same order can be subtracted and or added. So we are saying matrices of the same order can be added or subtracted by adding or subtracting corresponding elements. Okay, so we are saying matrices of the same order can be added or subtracted by adding or subtracting corresponding elements. So if we have matrices which have same order, we know that it is possible to add or subtract them by how? By either adding or subtracting corresponding elements. So let's look at some examples here. So the example can say simplify the following. So we can have like A can have 2, 3, then I can have negative 3, and then 1, okay, that is 1. Then B, I can have I can have like 1, 4, then I have again 2, 5, then I have 3, 6, okay, like that. Then I'm told plus, then I can have 3, negative 2, then I can have 0, 4, then I can have negative 1, 2, then I do it like that, then minus open brackets, I can have 6, negative 4, then I have negative 3, then 2, then 2, 0. So these are the two matrices that we are going to add and subtract. We have this question and that question. So to answer this one, remember we are told, first of all, the matrices must be of the same order, meaning the number of rows and the number of columns must be equal. So in this one, we have 2 rows, 1, 2, and 2 columns. Also in this one, 2 rows and 2 columns. So these ones can be added. So how do we add? By adding corresponding elements. So by corresponding elements, we mean elements that take the same position must be added or subtracted, like this one here. The position of 1 and the position of 2 here is the same. The position of 4 and position of 3 is the same. The position of 2 and position of negative 3 is the same. The position of 3 and 1 are the same. So these can be added when we are adding, because there is plus here. It means this matrix plus this matrix. So how do we add? Add the corresponding, like we say, like equals. We can get this one plus this one, because this and this have the same position. So we can say 1 plus what? Plus 2. Then this and this have the same position. So we can say 4 plus 3. Then this and this have the same position. So we can say 2 plus this is negative 3. So we'll say negative 3. Then this and this have the same position. So we can say 3 plus 1. So 3 plus 1. Then we do like this. Then we say equals 1 plus 2, it will be 3. 4 plus 3, it will be 7. Then here 2 plus negative 1. So 2 plus negative 3, I mean, it can come out like this 2. Then you say positive times negative, it will be negative. Then you bring the 3 here. Then you're saying 2 minus 3. 2 minus 3. So whenever you're subtracting a bigger number from a smaller number, just know that the final answer should be negative. When you're subtracting a bigger number from a smaller number, the final answer should be negative. Then you just say 3 minus 2, which is what? 1. So meaning here, this one, it is this one which has become like this one. So here we'll have negative 1. Then here we'll say 3 plus 1, it will be 4. So this will be the answer here. So we can also try to answer this one here. So this one corresponds to this 3 and 6. So it will be 1, then plus 3. So plus 3, then plus oh, here it's not plus. Here we have negative. So negative, then we get 6. Then this 4 corresponds to this, and that's also 4 here, plus this negative 2. Then we come to minus. Then we have negative 4 there, negative 4. Then this corresponds to this and that. So say 2 plus this is 0 here. Then minus. Then this 3 here. So say negative 3. Then this 5 corresponds to this and that. So say 5. This plus here. Then I'll put 4. Then I'll put negative. Then I'll put 2 there. Okay. Then this corresponds to this and that. So say 3 plus this one, then this one is negative 1, then minus, we say minus, then 2 here. Then this one corresponds to this, and that source is 6 plus negative or plus 2 here, then minus 0, then we say minus this is 0 here. Then we can do like this. So this is 0, okay? Then from there, we'll do this. We'll same. Then we'll same 1 plus 3, 4. 4 minus 6. So we have 4 minus 6. Again, I told you, since a smaller number is subtracting a bigger number, the final answer should be negative. Then we say 6 minus 4, 2. So here it will be negative 2. Then here 4 plus negative 2 is like we are saying, we just grab this part. I'll be using this part. So you're saying here, sorry, you're saying 4, then you say positive and negative. Positive times negative, it will be negative. Then you say 2. Then here negative times negative, it will be positive here. So positive, then you have 4. Then you are saying 2 minus c, I mean 4 minus 2, which is going to give us 2. Then 2 plus 4, it will be 6. So here we are going to have 6. Then we'll come here, we'll have 2 plus 0, it will be 2. Then negative times negative, it will be positive. Then we'll put 3. So say 2 times 3, 5. So here we'll have 5. Okay. Then here, we are going to say 5 plus 4 minus 2. So 5 plus 4, 9, minus 2, 7. So here we have 7. Then here 3. So here we have this. We have 3. Then we'll say positive times negative, it will be negative. Then we'll have 1, then minus 2. So say 3 minus 1, 2. Then 2 minus 2, 0. So we have 0 here. Then here we have 6 plus 2, which will be 8. 8 minus 0, it will still be 8. So this will be our answer like that. Okay, so negative 250 like that. So this is how we do the subtraction and the addition. Okay, so now let's look at the last part, which is the scalar. So we are going to look at scalar multiplication. Very important you understand. So a scalar is any number that is written in front of a matrix. So this scalar here, it is any number written in front of a matrix. So it's very important you understand that a scalar is any number written in front of a matrix. So we have to understand that each element of a matrix is multiplied by a scalar. So each element of a matrix is multiplied by a scalar. So that's what we mean. Example here is this. Okay. So I can say simplify the following. To simplify it is to make simple. Then I have m, um, 3 open brackets. I have 2, 0, 3, -1, close brackets, and b, I have maybe 4, open brackets, 6, 1, 3, then 2, 6, 4, like that. So these are the two matrices. So this number which is in front of this matrix is a scalar. And when they say simplify, they mean make something simple. So these are a little bit complex, but they want you to make them simple. So how? Because a scalar is in front of this matrix, you must multiply each element inside the matrix with this scalar here. So this one, the answer is going to be like this: 3 times 2, again 3 times 0, then 3 times 3, then 3 times -1, like that. Then it will be equal to 3 times 2, 6, then 3 times 0, 0, 3 times 3, 9, 3 times -1, -3. You close. So this will be the answer. So when you compare this and this one, this is simpler than this one. So you have simplified, you have made it simple. Then this one, it will be 4 times 6, so 4 times 6. Then again 4 times 1, 4 times 1. Again 4 times 3, 4 times 3. Then 4 times 2 also, 4 times 2. Then 4 times 6, 4 times 6. Then 4 times 4, 4 times 4. Like that. Then you say equals 4 times 6, 24. 4 times 1, 4. 4 times 3, that will be 12. Then 4 times 2, that will be 8. 4 times 6, 24. And 4 times 4, 16. So you end up having an answer like this. So this is simple than me. This have made this one simple according to mathematics. So now to help you understand these concepts that we have covered, I am going to give you this week here, which is going to help you to understand these concepts. So this is the exercise, and you put it here because of the reflection from the light. So I'm going to put number 1. Number 1, I'm going to say determine the order of the following matrices. So I'll say A 4, 2, 1, then B 6, 0, 4. This is B. Then C 5, 0, 1, then 6, 7, 4. Then that is ABC. D, I'll give you like 2, 0, 4, 3, 8, 9. So you have A, B, C, D. So you need to determine the order according to what we did in the first concept. Then number 2, I'm going to say find the transpose of the following matrices. So I have this matrix which is 2, 4, 1, 6, 3, 7. Then B, I have this matrix which is B again. We have said I have 0, 6, 7, 4, then 9, then 8, 4, 1. Okay, so we only have that. Then 3, I'm going to say simplify the following. Simplify the following. Okay, simplify the following. A, just going to put 4. This 4 is not good. So say from 2, 6, 7, 1, 0 plus, say 6, 1, 7, 2, 3, 4. Like this. Then B, I'm going to put like maybe 4, 0, 1, then 6, 8, 9, like this. Then minus, open brackets, I'll say 0, 6, 7, then 4, 2, 8, like that. So you are going to submit the answers to these questions in the group. I hope you have enjoyed this mathematics lesson as much as I have enjoyed it myself, and I hope it has been helpful to you for now. Bye and see you in the lesson.